And welcome to Digital Transformation with BIM. This is week 3 lecture. Okay, so we're gonna talk about project. So in a project, we need the project information is required, and with that, we need the exchange information requirement. And at the end of the day, you will be able to do the building information modeling. So why is this project information important? Because they are all related to the project approval. Since before a project is done, you need to have an agreement. Why is it needed? Then you have to agree on the concept of the design. You have to confirm, is it within your budget, the construction cost, and you have to accept the completed asset. So if you can see here on the diagram here, on a conventional construction way, you have the interested party information requirement, which is you start off with the organization information requirement, OIR, and then this will contribute into the project information requirement. So the interested party will have to inject the information into the project, what sort of design they want, how much budget are they willing to allocate, what are the agreement, what are the demands to do the project. So once this is decided, then you will move on to the appointment of information required. So you have the asset information requirement, AIR, then all these parties will contribute into the exchange information requirement, which is a EIR. So in BIM, we have another stage. So for conventional, if you can see, for conventional and for digital transformation with BIM, the first two parts are the same. But in BIM, we have the difference in information deliverable, which is a asset information modeling (AIM), and all of this will contribute to the project information model (PM), which is at the end of the day, you will be using the software and you'll be building up the model linked to in itself. So the project information requirement forms the basis for each of the EIR. They are critical at all stages of the project, and they form the guidance to how to appoint the parties to. And by having the guidance to appoint the parties, they'll be able to assess their execution plan. And as it goes on, as the project passes critical milestones such as the design phase, the construction phase, then it will become more and more detailed. So an exchange information requirement is by delivering all the asset. This is important because you need all the specific information for the project. So some of the EIR can originate from the asset management team when that information is generated by the project. This means that by knowing what sort of project you are doing, you can appoint the contractor or the architect to design what you want, and then the specialists will be able to inject their info into the model itself. So we'll have to cover, there's a lot of content to cover here. So an introduction. So there will be a Chinese whisper, because in construction, if nothing is written down, it'll be like I whisper once to you, the other guy will say another thing to another person, another person will say another thing to another person, and then it will be like a guessing game. So there's a diverse software in BIM, in the AEC market. The AEC stands for the architect, engineer, and the consultant. You can have the BIM modeling software, the Revit that you guys are doing for the tutorial, the Tekla you guys are doing for the practical, ArchiCAD, Rhinoceros, Bentley, and then the BIM construction software. This is for you to collaborate. The computation BIM software, where it's a process of utilizing the script and algorithm to solve real world problem, means this is more towards the construction phase. The LIDAR technology, this is where you use the laser to scan the area, and you get the real life data into the BIM model. And then the common environment data, This is where you manage all your model, you collaborate. There's a BIM Autodesk 360, Trimble Connect, Oracle, Revisto. So all these three, the BIM, the Trimble, and the Revisto will use the building information modeling, the Revit. You will all be able to collaborate in this software. But the Oracle is an exception. So for Oracle, it's more towards uh, it's more towards like Gmail. So the process is like Gmail. So you'll be able to send out email, you'll be able to attach your file, and then you'll be able to specify that this email is categorized by this is for foundation, should be directed to the consultant. And then they can set the deadline. When should it be completed? When should it be solved? When should it be resolved? Then you can also specify who you want to send it to. So it's basically like a Gmail with a variable component attached to it. There's also a cloud-based system where you can upload your file and share to your colleagues or share to everyone in the project. So it's basically like a cloud-based server where everyone have to collaborate. So more on the model authoring. So this is Autodesk, which you guys should be familiar with. You can create a model, you can put in all your furnitures in, you can decorate it, and then at the end of it, you can render it and make it look like a presentable architectural modeling tools. So you can also input the structural tools in it, as you can see here, and also M&E. So it's like a one-stop area for all the AEC, the architect, the engineer, and the consultant to input all their specialized. Then you have this is the view of the M&E. So the Revit extension file. So if you can see here, there's a Revit structure here. The best practice is to name it the TAUC best. This is TAUC is a university who did it. And then there's a file name here, which we'll cover on later on how to name the file correctly. And then with the Revit structure, with the Revit software, we will be able to do the construction drawing, like how you are doing in the using the AutoCAD. And with that, we also can generate the schedule for the first floor, the second floor, the third floor. We can also color it for different area with different color. So the strength of Revit is the AEC are included. The architect, the engineer, and the consultant, all of them can use the software. And it's a standardized template, means everyone are using the same one. You can do basic rendering with it, as a previously you can see. It will be a basic coloring, it will be a cloud work sharing collaboration, and the asset information modeling means that all the information, all the model that you do, they are parametrics elements, means if you click onto it, you can check what's their dimension, what's their height, from where the supplier is, what's the serial number for the furniture, or the yeah, and also API customization. So API means application programming interface, means that it allows for software to talk to each other, means you can use it on a cloud-based software. But this Revit software is not without its weakness. So it's not actually very well suited for automated fabrication, and the file size are very big, because as you put more and more information on the model itself, like where architecture put their elements on it, structural puts their structural elements on it, M&E put their element on it, and in one big federated model, the file can be very, very heavy, and it might take a very long time to load. So what about Tekla? So Tekla is mostly usage for construction modeling, although it's more suitable for structural. So you should not ignore it. So you use it for construction of steel, concrete, detailing, precast, cast in situ. So you have the file extension and you can do the shop drawing with it. So Tekla can cover the weaknesses in Revit, which in Revit they will not show you the bar binding schedule, but in Tekla you should be able to do that. And with that schedule generator, you can send it to factory and they can use the factory to fabricate out all the rebar, the shapes and sizes and length. So as you can see here, all of all the rebar are generated. So it's a good the strength of Tekla is a good production accuracy for offsite fabrication, organizer for construction zoning and scheduling, cloud work sharing collaboration, and you can customize all the quantities. But like I said, this is Tekla is only for construction modeling, so you cannot have any complex geometrics modeling. So it's not very suitable for architect. So next is the Naviswork. So Naviswork is basically a managing tool. You can have a walkthrough, you can have collaboration. So let's have a look at the walkthrough. So in Naviswork, you use the BIM model which you have done in Revit, and you use the software, the Naviswork software, and you can have a walkthrough through the model that you have done. So as you can see here, you can see all the piping and everything. So essentially, Naviswork is a construction tool for management. The management is not also limited to clash detection. If you can see at the lower left corner here, you will be able to do a timeline, which means you can see where the components are coming in. As you can see, the month, there's a timeline, the date, the month, and the component of when the thing is coming in, the construction percentage. So with Naviswork, you can essentially model out the construction phase. You can see the timeline on when the things are coming in, and you can do the you'll be able to do the scheduling perfectly. So it's not without its strength and weaknesses. So one of the strength is a visual design review. You can walk through the model. There's a clash detection analysis. It's automatic. It's automatic. So if you have a MAE clashing with your structural or your architectural, or if your architecture and structurals are not tally, they will highlight it out. You can search. You can remove all the minor. There will be a three types of clash: minor, major, and okay. So you'll be able to also do structural quantities takeoff. So one of the tedious tasks is like you have a lot of clashes and you have to group them properly. And the software platform is also sensitive. So that's about it for the Naviswork. So this is LiDAR technology. It's a ferro scanner. The ferro scanner means it's a scan. Means you put your instrument here, as you can see here. You put it here, and you scan. You'll be able to scan the area. By scanning this area, you'll be able to put. You'll be able to have the points on it. You will be scanning dots by dots, and with all the dots, you'll be able to combine and make up the model in the software. So if once you have scanned all, this is how you get out you see the data in your software. Previously, so this is a few example. of all the outcome after you scan it. So you'll be able to digitize all the existing building into the BIM model itself. So the accuracy of the scanner is quite high. You can go up to 6.1 mm, but do know that if you make it very accurate, it will take a very long time to scan, maybe up to 10 minutes. If you do not mind the accuracy, you can adjust the accuracy to be not so accurate, then it will take like maybe 1 to 2 minutes to scan. So one of the problem is because this is a scanner, if there's something hidden behind, then you will not be able to scan it. Then you have to take a lot of point. Means if you want to scan something that is hidden behind a wall or there's a partition in a room, then you have to move your scanner to a lot of point. So there's also a problem with witness with this scanner, which is because the way they scan is by taking in point by shooting out the laser, the file will certainly be very huge because there will be a lot of point. So as you take more point, then each of these point, the file size will be very big. So for this scanner, each point that you take is about 200 MB, depending on how accurate you want the model to be when you project it into your software. So Fusa. Fusa is a VDR solution. So let's have a look at the video. Okay, so Fusa is a workflow delivery software. So with Naviswork, like previously I have explained, Naviswork you'll be able to show when that component is being built. Like you have to build the foundation first, then you go towards your wall. But with Fusa, you can render and animate the whole construction sequence. which means that you do not just leave everything to the project manager to do the work. So you do your hope you hire people to do your homework first, means that you have people to animate what could go wrong, what things should go in first. So with this way, you will not have any problem, or there will not be any problem inside where a contractor wants to install this first because he will just want to get his job done and get the money. So with a FUSA, you will be able to render and animate the sequence of the construction. Who should install their equipment first? Okay, onto the computation BIM. So computation BIM is, like I said before, as a process of utilizing scripts and algorithms to solve real-world problem. So let's have a video on what it is. So you can see that is clicking from one component to one component. So by clicking from one component to one component is specifying that how many rebar should it have, how many bars, how many layers the rebar should be at, how long the component should be. So it's a which means at the end of the day, this is they are setting the parameters. So there's a set parameters in it, and you click and you just drag on it. So it is a pretty friendly visual software. So you can see it's adding layers of concrete, layers of rebar into the. I think this is the highway. So this software is a grasshopper. So as you can see, once it's click all the parameter, all this rebar has been generated on the screen next to it. So Dynamo is the same. So like as you see before, the strength of it is a very user-friendly visual program. You'll be able to create a lot of complex modeling with it by just click and drag. And once you click and drag on the parameters that you set, then it will easily generate out the model. So if you do not have the parameters set, you can easily download it online. But if you want to do something that is not available on net, then you will need to learn programming language, and this software is not very stable. So at the end of all that, since we have so many different software, so we will need to know about what's IFC. So IFC is having a one file format, which means that all the files are editable. They will not require any specific software, and they can interchange from this. They can be ported from one software to another software. They also have to be secure, and it's an open format. So as I covered before, all of them are interconnectable. Their processes can be linked to each other, easily identifiable by the machine. You do not have to have a special machine to read this file or software to read this file. We just need the software that we have available, and we can easily port it into our software. So this is all the types of the software available, just for info. And oops. So what is OpenBIM? So OpenBIM is a universal approach to the collaborative design, realization, and operation of building based on open standard and workflow.
What OpenBIM does for you. Why the AEC industry needs to change. The building industry has experienced negative growth in productivity in the last decades. The building industry is divided into many specialized disciplines. In order to design, construct, and operate a building, all disciplines have to work efficiently together with the same information. In conventional processes, information is exchanged on paper. This makes room for many different interpretations, mistakes, and errors. In all conventional projects, expensive errors are made due to lack of coordinated information. Often, time schedule and budget are exceeded. How does it change? By sharing all information between all actors in one open format, everyone can work efficiently without errors. A building information model, or BIM, is a digital representation of the real building. Each object in the real building is represented by equivalent digital objects in the BIM. All building information is shared by one open format called IFC and a standardized terminology called data dictionary. All project actors can access relevant information when they need it so that everyone can work efficiently together. How do we want to work? Let us give you an example on how we want to work with the building information models. We want the school! The client document their requirements in a database that follows the project the entire life cycle. The design team designs the building according to the client's requirements. The building is modeled by numerous digital objects. One of the objects is a door. The door is chosen from an object library in the design software. The design software automatically adds information about the position of the door. The consultants add information and requirements for dimensions, material, color, fittings and surface, thermal transmittance value. The architect positions the BIM in a digital map to enable the contractor to know exactly where to build the school. The project team uses the BIM to coordinate the disciplines and to analyze project cost, analyze life cycle costs, analyze energy performance and other environmental impact factors for environmental certification. The BIM is sent to the local building authorities to get a building permit. The authority's BIM server automatically checks the building and approves the project. The contractor uses the BIM to plan construction, to communicate with building product vendors to get quotes and environmental information on all the building components, including the door, make their own cost estimation. The contractor accepts the best offer from the product vendors. Automatically, all product information is added to the BIM, while the real door is transported to the building site. The property caretaker identifies the door with his handheld device and registers the damage. All the door information is available at hand, and he can order new parts on site. The glazier repairs the door. The event and all information about the new parts are registered in the BIM. Building Smart is the solution. Building Smart's IFC format exchanges geometry and object information. IFC exchanges the building model. Building Smart Data Dictionary standardizes all types of entities, properties, and classification. The data dictionary ensures that all software understands the information in the building model. This is how we make the building industry work more efficient and produce more resource-efficient solutions. We need to document and share all information by one open format using one standardized terminology. That is Building Smart. Building Smart for a sustainable building industry.
Okay, so in summary, open BIM is all about being transparent. Means you're sharing all the information. So IFC is in short, IFC is industry foundation classes. Like the video says, all the parameters set onto the elements, they'll be able to interchange perfectly. So you will not lost any data in between when you're porting it from one software to another software. So so BIM in essential is a software, but when you are talking about BIM in the construction industry, it's not just about the software. BIM is on Revit. The terminology is building information modeling, but in a wider view, it's more on the collaboration and the to smoothen out the workflow progress to increase the productivity so that the AEC industry do not keep repeating the same work again and again. So why is it important? as I said before, is to support transparency. When everyone is transparent, then everyone will not have to guess what each of the parties want. Create a common language, which is the IFC. We will be able to port it from different software to different software by keeping all the parameters in touch. You provide enduring project data. So this is important because the building build is not just because you are building it for the profit. We also have to take care of its life cycle. But the previous video shows that if something break, then by having this BIM model, you'll be able to access the like the previous video, the door that has broken. We will be able to know, oh, the supplier, this is their supplier, this is the serial number. There will be also be a contact info. You just contact the supplier, you give them their serial number, and there's also the price indication. You try to get back the same price to maintain the building. So the last is a small and large platform software vendor can also participate and compete on the system independent best of breed solution. Means that everyone can input their price into the software and you get best price. This is this is very good for the owner of the project if they want to keep their cost down, which means that it's an open tender. All the vendor can put in their prices. Okay, the last is the Open BIM energize the online product supply side with more exact user demand search and deliver the product data directly into the BIM, which means that if you want to search anything on the model, you can easily search it because it's as the technology is getting more and more advanced, everything is getting easier and clearer with a click of a button. So BIM, there's two ways of doing BIM. One is a single multi-discipline, another is a federated model. So if you are working on a single multi-discipline, you have a very big size because everyone is working on just one general model and everyone will have to be limited to one software tool. So in this case, a single multiple discipline can be a Revit. But on a federated model, each of the specialists can work on their own model. And by doing a federated model, the architect can use their own software, specialized software, to produce the the model. It could be the 3D Max, or the contractor, the consultant, they'll be using Tekla, or the MA, they will have their own software. And by having their own software, the model size will be controlled because each of them are doing the model at their own platform. And with your own platform, you'll be able to split the load. And by having the model at each place to collaborate, you just upload it onto the cloud, and you just use Naviswork to to do the clash detection to see where the things have gone wrong. So a single model you have only one, a federated model you have three, and you combine all these three onto one model on a cloud-based software. So essentially, a single and a federated model is the same, but if but the best is you go for federated model because you will not have a very big size and you will not be limited to only one software because one software can only do so much. uh, Normal software will not be able to produce a very good rendering, produce a very good taking off structure. So we want to have a federated model. So with a Naviswork, you can have a clash analysis. You have a piping here. You have a insufficient ceiling headroom for waste pipe. This is case one. So you can see at different base what's the solution we should do. Maybe we increase the AC latch size. More on the clash detection side, it will be highlighted up. So at the end of it, if you'll be able to generate a class rendition report. So in this case, this is the class rendition report. The architect, all the parties have to agree what they should do to solve this clash problem. So here there's an M&E duct clashing with the structural trusses. So architect have to agree they want to push up the tennis court to increase the height of the MPH, in this case this area, and then the CNS will have to allow the MA to pass through their structural. They have to make allowance, and then the MA have to revise their drawing. So you can do a virtual design review. Once the model is done, you can have a virtual walkthrough of the model. As you can see here, there's the 2D top view of the model, and you can walk through your model. So it give you a view of the model before you build it. So you can see that you can walk through and you can hide all the element in it. You can see all the piping through the model. So as you can see here, there will be an indicator that you are walking and where you are viewing the model. So if you view it and you feel that there's a need to change the spec of the, like in this case, the railing, so you just highlight it up and you just put put it up on put the comment on it. They change it to MS railing or whichever you like. This is more towards the design. If you want it cheaper or you want it to look better, there will be these sort of changes and comment. So with this BIM modeling tool, you'll be able to do the architectural quantity takeoff. You have the skin code, the plaster, what's the area that you need to cover, the structural analysis, quantities takeoff, how many wall you have in total, how many bars, in this case this is the rebar size, how much in total the kg you are required to have for this area. The M&E, this is the pipe schedule, how much pipe, how long the pipe need to be, at what size. So with all of this, you'll be able to have a model sharing in the CDE, which is a common data environment. So all of this info in one model, and if you want to know what this is, you just click on it and you'll be able to view the info on it. So in conclusion, because construction has been the slowest to utilize technology, if you are to implement technology into the construction practice, the cumulative impact will be a lot. You'll be able to improve the productivity. That's the one. And not only productivity, in the end, it's all about costing and making sure that no problem is occurring during your construction. And then after the construction, you want to make sure the building is being maintained at a very efficient state. So Amazon is a good example on it. They are utilizing the technology. They are doing the app store, music, opening their physical store. So books are changing from hard copy to electronic copy. So this tutorial, uh, hope you guys study through it and remember about it. So bidder should be required to provide as part of a bid submission to demonstrate BIM capacity and experience. So if you do not have any experience in BIM, you will not tender successfully for the project if the project requires you to have BIM capability. So the sponsors will need to describe how mature an organization is and what capability are held specifically where there is in accordance with the standard cited in this EIR. So EIR is the Exchange Information Requirement. So what should the tender include in detail? So the BIM specific competence requirement, they'll need to know the approach to BIM, what's the organization culture towards the BIM, their experience on BIM, their capability, their security understanding, and if there's any outsource role when they are dealing with BIM. So if the to accept a project where BIM is required, the company first have to have the software. Then the second, they need to have the capability, the capable people who are able to use the software. And then how long have they been using the software? How skillful are they at using the software? Once all of this has been identified, then if you have a track record of implementing BIM into when you do a project, then you should be able to easily bid for the project that is required BIM. Okay, so that's about it for week 3's lecture. Okay, thank you.